to today's lesson of Line Up Best Fit Day 2. So, as the week progresses, we're just going to keep adding to everything that we have learned. So on Monday, we learned how to create a scatter plot. On Tuesday, we learned how to draw in a line of best fit. And today, we're going to learn how to then now write that equation for the line of best fit. And then explain kind of what it means in real life. Today's theme is kind of cool. It was an idea suggested by a student from last year, and they wanted a countdown of the top 10 all-time leading scorers in the NBA. So number 10 here is a guy named Elvin Hayes, and he had 27,313 all-time points. Then we have Moses Malone. You can see his points there, 27,409. Number 8 was what we started off with, which was Shaq, 28,596. And as the lesson goes on, we will count our way down to number 1. Okay, so the first thing that we have to do, and this is not technically in your notes, it's kind of like a side Word document that I attached to the lesson, is to practice choosing the correct points. Okay, so we're going to do 2 examples like this. So first off, if you can see the scatter plot, okay, we have a bunch of those blue points all over the place. What you have to do is to totally ignore all of those points, almost like if you had whiteout and you were going through and you were just marking them all off. And the only thing that you are focusing on is that navy blue line. So that's what you need to think about when you're trying to identify points on your line. It's just like we did before, but sometimes people get confused because they see those other points all over the place, and you have to kind of put on special glasses that take away those points and you only see the line. Now, to make our work easier, we're going to identify the first point as our y-intercept. Okay, so that's why yesterday I always had you start your line at the y-axis. Okay, so the first point would be right here on your y-axis, and that point is between, well, it's always 0, and then it's between 8,000 and 12,000, so halfway in between there would be 10,000. Okay, and then you always want to choose a point that is close to that. So that one doesn't work, that one doesn't work, but this one does. And the x is between 200 and 400, so 300. And our y is between 12,000 and 16,000, so that would be 14,000. So those would be the 2 easiest points to choose. Okay, so let's practice another one like that. If you want to, you can pause your video now and try it on your own and then play and see if you got it right. Okay, so here's what you should have gotten. The first point, our y-intercept is the point 0, 0. All right, our second one, there were some that were really close, like this one looks close, but that wasn't one, that wasn't one, that wasn't one, but this one is, that is the point 16 and 12. And that would probably be the 2 easiest points to use. Okay, so now that we practice choosing the points, and again, when you do that, you ignore the points around the line and you just look at that line. Okay, so keep that in mind. Okay, so now we practice that. We're going to move on to using those 2 points to help us write an equation for the line of best fit. And we've already done this in the last chapter, so this should be kind of a review. So we're going to pick the 2 points like we just did. We're going to use them to calculate our slope. And then we are going to find, well, we're just going to write them in the formula because we already have the b, the y-intercept, and we already have the m, so we just have to plug those 2 things in. All right, so let's see what this looks like. Here we have the cost of a cell phone. All right, so first identify the 2 points. Again, use your special glasses or whatever, however you want to think about this, but totally ignore all the blue points and just focus on the red line. And I am going to choose the y-intercept, which here is 0, halfway between 10 and 20 would be 15. Now I'm going to, again, you don't pretend like you don't see any blue line or blue points. and I'm looking for the next point on this line. It would not be there, but there is one there, and that is 200 minutes and $20. All right, now we're going to use those 2 points to find slope. It's up to you if you want to look at your graph to help you see the rise and the run, or if you want to use your 2 points by making it a table to see the change in the X and the change in the Y. Either way, you should get the same answer. Our rise was 5, no matter if you look at the table or if you look at the graph, and our run was 200. Again, it doesn't matter if you look at the graph or the table. And just remember, it's rise over run or y's over x's, so 5 over 200, which would simplify to 1, if we divide them both by 5, 1 over 40 is our slope. So if we write the equation, we just have to put those a and b together. We had our y-intercept, and now we have our slope. So y equals mx, so m is our 1 over 40, and then x, and then plus our b, which was 15. And that is our equation. You guys have been getting better at explaining what this means in the real world, but we're going to still kind of practice it. So our slope, what is the slope? First off, you have to say what it is. That's our m, so 1 over 40. And what does it represent? So again, it's rise over run. So look at your axis that rises. That would be your amount of the bill. It says in dollars. So this is $1 per. Now you're used to just saying per something, but this time, since it's 40, we have to actually say $1 per 40. Look at your running axis. That is minutes. So it is $1 per 40 minutes of being on your phone. And I know you guys pay more per data, but this is how it used to be done before people had smartphones. All right, last question here. What is the y-intercept and what does it represent? Well, the y-intercept is our starting point, so 15. And this is kind of a hard one to explain. Why would 15 be the starting point for your cell phone bill? Well, maybe that's what your plan costs. So your plan costs $15 right at the beginning. All right, we're going to go on to example 2 here. All right, always look at the title first. So this one is about lawn service and the amount of money that they bring in. Okay, so our x-axis is our yards mowed and our y-axis is the amount of money that they bring in. Okay, so again, put on your special goggles, ignore all the blue points and focus only on the red line. And we are going to select 2 points. The first one needs to be the y-intercept. Our y-intercept is the point 0, 0 this time. And we need another point. There's not one at 5. There is one at 10 though. That is the point 10. And halfway between 200 and 400 would be 300. For people that are struggling with finding that halfway point between numbers, you can always take the 2 numbers and add them. And if we're finding halfway between, you would then take that and divide by 2. That's a way that you could do it on the calculator if you're having trouble finding what's halfway in between 2 numbers. Okay, so now that we have 2 points, you can use your graph to find the slope of rise over run, or you can use the 2 points and create a table to find the rise over the run. So 0, 0, and 10, 300. Our rise, or the y's, we're changing by 300. That was our rise. And our x's, or our run, was changing by 10. Again, if we make a fraction out of that, rise goes on top, or the y's go on top. 300 divided by 10 would be 30. Okay, if we put those 2 parts together, a and b, our y-intercept and our slope, we would get the equation of y equals not m anymore. We know our slope is 30. So we have 30x plus 0, or a lot of times we will just write that as y equals 30x. Okay, so now let's explain what this means. So our slope was 30. Again, a lot of times we'll write it as a fraction. And it's rise over run. So look at your axis that's rising. That is $30. So $30 per, and our run is yards. So they are making $30 per yard that someone mows. Now they're not talking about yard as in 3 feet. They're talking about like somebody's yard for their house, the entire yard. They don't make $30 for every 3 feet that they mow. They would be very, very rich if that was the case. All right, and the last one, what is the y-intercept and what does it represent? Well, our y-intercept was 0, and explaining what that means is that if they mow 0 yards, they make $0. And that makes sense. No one's going to pay them if they don't do any work. Okay, and I kind of forgot to go back to our theme here. So number 7 there was Wilt Chamberlain with 31,419 points. Number 6 you just saw was Dirk, and I'm not going to pronounce his last name because I know I'll butcher it. 31,560 points. And number 5 on our list of all-time leading scorers in the NBA is Michael Jordan. I bet you guys thought he was higher up, but he's number 5, 32,292 points. All right, I'm going to do one last one like this. This one is a little bit different. It's pretty tricky. Again, if you remember in the last one, I said always look at the title first. So we're talking about used car value, how much money it's worth. And then I also like to look at the axes. So the x-axis is the time since we purchased it in years. And car value is in thousands of dollars. Okay, so identify 2 points on the line. So first is your y-intercept. Where does it start? A lot of people are going to say that this is 0, 11, and that is incorrect. Because you have to be very careful of the scale. Used cars are not going to start off costing $11. Notice it says in thousands of dollars. So this used car that we bought, or somebody bought, started off costing $11,000. Okay, so be careful with that. We need to choose another point close. 1 year, there's not a point. 2, nope. 3, nope. 4, there is though. So we're going to use the point at 4. I'm going to see if it continues that pattern of down 3, right 4. So down 3, right 4. Yep. So that means I have a good slope because it follows that pattern of down 3, right 4. But that was after 4 years, the car cost not $8, but $8,000. Okay, so we're going to find the slope between those 2 points. Again, you can use your table or you can use a graph. I know a lot of people like using both methods, so I'm showing both methods here. Okay, our rise changed from 11,000 to 8,000. We went down not 3. If you look at it, the graph, you might be confused by that, but it went down 3,000. Again, the table is kind of easier to see the 3,000 versus the 3. And our run went from 0 to 4, so 4 years. So negative 3,000 over 4. We could divide those both by 2 to get negative 1,500 over 2. And again, I can divide that by 2 one more time, and feel free to use a calculator if you would like on this. But 1,500 divided by 2 is 750. So negative 750 is our slope, or negative 750 over 1. And when we write our equation, we put in the two things that you already found, our y-intercept and our slope. So y equals negative 750, x plus 11,000. All right, so which one of those is the slope? Well, it was the negative 750 over 1. What does it represent? We need to add in our labels. Remember, it's rise over run. So negative 750 goes with our number of dollars. Okay, so but we have to put in something about it being negative. So I'm going to put the car's value dropped $750, and then we put in the per for the fraction. And since it's 1, I don't need to put 1, but you can put 1. And it's the run, so per year. So every year you drive the car's value decreases. What is the y-intercept and what does it represent? Well, if you remember from our equation, or from part A, it was $11,000. And usually people have a hard time explaining what that means. So remember, the y-intercept is always the start. Okay, so think about what that means in this problem, the start. That is when we bought the car. So the car costs $11,000 when we bought the car. Okay, now here's where we would have our commercial break. I'm still going to show you the slide so you can see who was the number 4 all-time leading scorer. And that was Kobe Bryant, 33,643 points. Number 3 here is LeBron James at 33,655 points. And we're going to do this problem before you see number 2. Okay, it says the graph shows a line of best fit for data collected on the distance bicyclists have remaining in relation to the amount of time they have been riding. What is the equation for the line of best fit? Now, normally we have a nice, easy y-intercept that we can use to start with. Okay, but I don't. So one way to kind of reason through, especially if it is multiple choice, is to look at your options, the y-intercept options. Notice they are all the same. They are all 170. So I know our y-intercept is 170. Okay, so I don't even have to worry about that part because they all have that in common. All I really need to do is to find the slope. So you can use the point 0, 170, or you could use other 2 points that you see on the graph. Like I know, for example, that there is another point at 620 that looked like a good point, and at 120 also looked like a good point. So maybe I use 0, 170 and I use the point 2, 120. And I find the slope between them. So I'll use a table, t-table here. So 0, 170 and 2, 120. All right, so let's see what our change was. Our y's went down 50 and our x's went up 2. So if I make my fraction of negative 50 over 2, that would give me a slope of negative 25. All right, one other way that you could reason through this is, one, if I have skier Bob here, I know that I am going down this line. I know my slope is negative. I could have already taken off B and I could have taken off D. Now, some people might choose C, because if they just count down from the 2 purple points I have there, if they count down 5 and over 8 boxes, we would get to that point. But that what they did wrong is that they didn't follow the scale and pay attention to the scale. So it's not C. Our answer here should have been letter A. All right, let's try one last one together here, and then that will be it for the lesson. Number 2 all-time leading scorer is Carl Malone, 36,928 points. All right, last question. The graph shows a collection of data on how many miles runners need to travel to finish a race. It says draw in a line of best fit. Then we're going to have to use that line of best fit to kind of go from there. So remember, when we draw in a line of best fit, we have to have a y-intercept. So it has to start at the y-axis. Now, if we look at this data, I think there's going to be a line going straight down the middle of it. So I'm going to start right at 70. And if I keep it straight down the middle of it, it's going to give me a nice slope. It's going to be down 1 box, right 1 box, down 1 box, right 1 box. Make it easy on yourself. Okay, so let's find our 2 points. We said 0, 70 is going to be our y-intercept. We did that again to make it easier on ourselves. I see a point at 160. Again, I made it a nice slope so I could calculate it easily. So 160. All right, using those 2 points, find the slope. Again, you can use a table, 0, 70, 160. The change of the rise, it went down by 10, and the run was up by 1. So our slope is -10 over 1, or -10. Put those 2 parts together, your slope and your y-intercept. So y equals -10x plus 70. And let's talk about what those 2 parts mean. So what is the slope? That was -10 over 1. So something is dropping 10. But what? Well, let's check our rise. The distance yet to travel. Okay, so they have, oh, it doesn't say if it's in miles or what, but let's pretend like it's miles. They have 10 less miles to travel per, and it's hour. So per hour, they ran. And last question here, what is the y-intercept and what does it represent? The y-intercept is 70. And that means that they started with 70 miles to go. All right, that's it for our lesson. I will let you see the number 1 all-time leading scorer, and that is Kareem Abdul-Jabbar with 38,387 points. All right, there is a homework, a worksheet to go along with today's lesson. Please try this on your own and then check your answer key. This is usually a tougher homework, and this does take some practice. All right, hope to see everyone soon. Bye.